Auzubillahi Bismillahirrahmanirrahim. Start with the name of Allah Almighty, who is the most beneficent and merciful. First of all, I want to say Assalamu alaikum to everyone. I hope that all of you will be fine. So, dear students, this is the first part of my video. In this video, we will discuss about the topic of barometric formula or barometric law, or you can say that distribution barometric law. In this video, we will discuss about the barometric law. We will discuss the definitions of the barometric law, we will discuss the figure of the barometric law, and we will discuss the mathematical steps and mathematical equations of the barometric law. So first of all, I want to tell you that in a barometric law we study the variation in a pressure. We study the variation in a pressure with respect to height. In a barometric distribution law, when we increase or decrease the pressure, then the height will be affected. So the pressure is depending upon the height. When we increase or decrease the height, as the same way the pressure will be affected. So first of all, we will discuss the definitions of the barometric law. The barometric distribution law deals with the study of variation in pressure with respect to height under the influencing of the gravitational field. The barometric distribution law may be defined as the barometric distribution law deals with the study of the variation in pressure with respect to height under the influencing of the gravitational field is called the barometric law. So now we will talk about the figure of the barometric distribution law. So you can see the figure of the barometric distribution law in this video. So let us consider this is a container. The cross-sectional area of the container is A, and the height of the container is H, and G is the gravitational field which is acting vertically downward, and here external pressure is acting vertically upward. This is a piston. This is a piston of the cylinder. So you can say that this is a container, or you can say that this is a cylinder. So the cross-sectional area of the container is A, height is H, gravitational field is G, and external pressure. So let us consider we fill the container with the gas. When we decrease the pressure, the piston is moving upward. When the piston is move upward, then the height of the container is changed. The change which comes to in the height of the container is delta H. And as when we reduce the pressure, the decrease in the pressure is the P minus delta P. And the external pressure is acting on a piston vertically upward, and the gravitational field is acting vertically downward. So now we will talk about the mathematical equations or mathematical steps of the barometric law. Then, as we know that pressure which is equal to F beta A, pressure may be defined as the force at a per unit area. The force which is acting on a per unit area is called the pressure. So the equation of the pressure is P, which is equal to F over A. And as we know that F, which is equal to W, which is equal to mg, force which is equal to weight. So then when we put the value of the force in this equation, then this equation becomes P, which is equal to mg over A. Here A is the cross-sectional area of the container. For a small change in the pressure is delta P. Then this equation becomes delta P, which is equal to delta mg over A. We apply the delta operator on both sides of this equation. So now we put the negative sign. It is because the pressure is decreasing. We are decreasing the pressure. That's why we put the sign in these equations. So when we put the sign negative in this equation, then minus delta P, which is equal to dmg over A. So now, as we know that density which is equal to mass by volume. Density may be defined as the mass at a per unit volume is called the density. So here V is dividing by mass, and when we transfer the V into another side, then rho is here rho is multiplying, and in this side the rho is dividing. So the equation becomes m over rho, which is equal to A cross H. This is the other form of this equation. So first the rho which is equal to m over V, and here V is dividing by m. When we transfer the V into in this side and density in this side, so equation becomes V which is equal to m over rho. So as we know that the volume of the container V which is equal to A cross H. A is the cross section area and H is the height. So we can determine the volume of the container. So as we know that this equation is a V which is equal to m over rho, and this equation is a V which is equal to A cross H. When we compare these both equations, then we get a final equation. So final equation is the m over rho which is equal to A cross H, and here density is multiplying with mass. When we transfer into another side, then here it will be multiplied with A and H. So equation becomes small m which is equal to density multiplied by area multiplied by H. So here m is the small mass, and rho is density, and A is area, and H is the height. For a small change in a pressure, so for a small change in a pressure, and in a when the small change occurs in a pressure, then the mass is also changed. So we apply the del operator in this equation, dm which is equal to A rho into dH. Here A is the constant, density is also constant, so H is the height which is changeable. So we apply the del operator with it. So now when we put the value of the dm in this equation, when we put the value of dm in this equation, then this equation becomes minus delta P which is equal to A rho into delta H into G, our A. So here at upper side and lower side A is same, so A is cancelled to each other. Minus delta P which is equal to rho into delta H into G. This is the remaining equation. For an ideal gas, we know that PV which is equal to nRT. This is the general ideal gas equation. So as we know that here n is the number of the moles, P is the pressure, V is the volume, R is the general gas constant, and T is the temperature. So as we know that number of the moles of the gas which is equal to mass over molar mass. Here small m is the mass and capital M is the molar mass. So when we put the value of the n in this equation, then this equation becomes PV which is equal to small m over capital M multiplied by RT. So here m is a dividing. So here m is a dividing. When we transfer the m into another side, then in this side m will be multiplied with P. So this becomes Pm. And here RT is multiplying. So when we transfer the RT into another side, then it will be dividing by the Pm. So this equation becomes Pm over RT. And V is multiplying with P. Then we transfer the V into other side. Then it will be dividing by the M. So this equation, final equation becomes Pm over RT, which is equal to small m over V. So this equation will becomes equal to density. It is because as we know that density which is equal to mass over volume. So this is the first part of my video, and in the second part of my video we will discuss the other remaining equations of the barometric law.